In this video, we are going to talk about pH and buffers. pH, you can kind of think of it as parts hydrogen. It is a measurement of how much acid is in your solution or your substance. And we look at that in terms of the concentration of hydrogen ion. Now, an increase in one pH unit is going to correspond to a tenfold increase in the amount of hydrogen ions present. So, pH is really a way to express the concentration of the acid. And remember, the acid is usually in terms of hydrogen ion because it produces hydrogen ion in solution. The pH scale goes from 0 to 14 for this class, and 0 to 7 is where we have our acidic substances. 7 is neutral, and above 7 to 14 is where we have our basic solutions. So here are some common everyday things we use, and they're different levels of pH. So things like soda, citrus, those are very acidic. Blood is slightly basic. Ocean water is also slightly basic. And then when you start getting into these really intense drain cleaners or cleaners, they're going to be quite basic. Now, buffers are solutions that can resist a change in pH. They resist a change in pH. Now, they are made up of very specific things. So it's going to be a mixture of a weak acid and its salt. So the way you can figure out what the salt is going to be, just take away the hydrogen and see what's left over. So an example of a swimming pool buffer is bicarbonate and carbonate. So all we did to figure out the salt here was take away a hydrogen. Now keep in mind that most of the time you won't find these as carbonate. You would find it with some sort of soluble cation. So something like Na2CO3 is a great example of the salt that goes with bicarbonate. Our blood has a very specific pH, and there's really no room for change, right? When I say no room, there's slight room. The pH of most people's blood is around 7.4, and if it drops below 7 or above 7.8, then bad things can start happening. So it's very important that we have buffers within our blood. And so in our blood, the carbon dioxide in our body is going to react with water and it forms carbonic acid. Well, carbonic acid is not one of the acids found on the strong acid chart. It is a weak acid. So we know that it can be used for a buffer. So if I know carbonic acid is a weak buffer, then I need to figure out the salt. I'm going to take one of these hydrogens away, and that will tell me the salt. Now, again, keep in mind that you won't find just bicarbonate by itself. You might find something like sodium bicarbonate. So when you're trying to identify a buffer, look for components that are going to be the same. Look for weak acids and something in the salt that is also in the weak acid. The way a buffer works is if you add acid, H plus, if that enters our bloodstream, then it can react with the bicarbonate to form the carbonic acid. If base enters the bloodstream, then it can react with the carbonic acid, and notice it forms the other part of the buffer. And so these different components of the buffer system are going to neutralize any acid or base that is added to the buffer. Now, keep in mind, if I have 5 milliliters of blood and I add 10 milliliters of acid, then obviously the buffer is not going to work. This is going to just resist the change in pH when small amounts of acid or base are added. So we'll only neutralize it if we have small amounts of that acid or base. Let's look at some examples. Identify whether the following pairs would make a buffer. So HCl and NCl. We'll look at the first one together. HCl, the first thing I'm going to do is remember my strong acids. And my strong acids are HCl, HBr, HI, HNO3, H2SO4, HCl4. So these are my strong acids. If my acid is on this list, it cannot be a buffer because it's not a weak acid. It has to be a weak acid because you have to have it exist in equilibrium. If it doesn't exist in equilibrium, then it's not going to neutralize the acid and base that get added to the buffer system. So this first example has HCl. Well, HCl is a strong acid. So I know right away that this cannot be a buffer. It is not a buffer. And it's not a buffer because HCl is not a weak acid. Let's look at my next example, HF. Is it on my list? Nope, it is a weak acid. So now I need to see if the salt is from HF. Notice how in HF I have fluorine. If I take away the hydrogen, that would be that would mean I'm left with fluoride. So I would need a salt that contains fluoride. This is not a salt because it is a base and it does not contain fluoride. So the B is also not a buffer. In this next example in C, I have an acid here. I might not know what acid it is, but I know it's an acid because it starts with hydrogen. So if I take that hydrogen away, I'm left with C2H3O2. I need to make sure that my salt contains that. And when I go look at my salt, look at that. It does. So this is a good example of a buffer. Finally, I want you to come up with a salt that can make a buffer with HF. HF, we already saw, was a weak acid, but it did not make a buffer with sodium hydroxide. In fact, if you took HF and you put it in NaOH, it would cause a neutralization reaction and you wouldn't even have any acid left. So, what salt would work as a buffer with HF? Send me that response, and that will be part of your quiz on chapter 6. It's going to be the last question for the chapter 6 quiz.